G'day, I'm Josh from AusPac Solar. I'm out here east of Emerald. This is central Queensland in Blackwater. We've had a client who owns an Earthworks company and they've engaged our services. Originally, the customer's energy needs were that they were spending about $1,500 to $2,000 a week in diesel, and that was at recent pricing, not assuming any inflation in the cost of energy. So I just wanted to go through some of the design aspects and also installation specifics of this. So I'm the off-grid solar installer and designer. I'm a CC accredited installer designer. I'm also an electrical contractor as well, an electrician, and I have been for close to about 15 years now. Obviously took a lot of knowledge and experience to get here, but we have got here and the system is currently functioning. What we did first is we provided a solution where we could financially, because budget is a part of the design requirements, the budget needed to be one which the customer could afford and also get a return on investment within 5 years, which with our projections we will well and truly be within, according to what they're spending on their energy, or they were on their diesel off grid. They didn't have the option as well to go on grid, and with the cost of diesel ramping up dramatically, at the moment it's about $2.20, $2.30. That's going to estimated within 12 months to be around $3. They needed to do something now to secure their energy needs for the future. We've done 224 solar panels on a ground mount that you can see behind me. The panels are under 100 kilowatts. Now, the reason we've done under 100 kilowatts is because the federal government offers STCs per property up to 100 kilowatts. If you go 101, then you are not eligible to receive any funding from the government. So they received approximately $45,000 from the federal government towards this project. Financially, it was very viable for them to do. This site has the capacity to generate approximately 400 to 600 kilowatt hours a day. The issue can be storage, of course, which we'll go into later. So the customer's purchased a 66 kVA genset. The output per phase on this generator is approximately 83 amps per phase that it outputs. We don't use that, but we do use more than 50% of what it generates. Minimum output is 33 kVA. The generators are very uneconomical, especially with fluctuating loads, which you see a lot on private dwellings and small commercials. But what we have actually done to stabilize and make this an efficient user of fuel is we've also coupled a set battery charge function as well to stabilize the output. So we're running this genset when it is running at between 60 to 70%, depending on how heavy the loads are as well. But what that means is every litre of diesel that goes into this generator, it also has a 2.5mm battery charger that runs off the solar when this isn't operating, so that the battery stays charged to start up the genset. So the customer's main switchboard is over there. Originally, that is what the generator, the genset, which you can see behind me, and that the customer had arranged was running directly to. That cable actually runs over to here, but nonetheless, we're capped at 100 amps that the site is receiving, so it wasn't a problem with the size of the cable. So the cable comes up here from the customer's main switchboard and comes to this switchboard here. Now, in this switchboard, it runs to this 100 amp three-phase breaker, and that is fed from this Solax parallel box that you need to purchase from Solax. This swaps between the genset and then the off-grid terminals of the inverters, which we'll go through shortly. So now we're going to talk about the inverter and the batteries. This here is the master inverter. I'm just going to focus on this section. There is one master inverter. All the batteries are identical, which they have to be for the output. The wiring to start with, work through, we have the genset that runs into the main switch of that switchboard, and from there we'll actually run to this AC isolator, and then from that AC isolator we'll actually run to the grid side of this inverter. Okay, so there's two output terminals. There's the grid terminals, and then there's your EPS, which is emergency power supply, or your off-grid terminals. We have the battery isolator, and then we have also, and this is the backup side now, so from the backup terminals it runs through to here. This is an isolator but also a circuit breaker, so 40 amp circuit breaker. From there it runs back to this parallel box, and in the parallel box we have our EPS terminals and we have our generator terminals. So this feeds back to that switchboard, which feeds the main switchboard. The grid here just simply swaps between the two. All roads lead to Rome, and this is Rome. Without this, we wouldn't be able to have this system. In regards to the inverter, This master inverter in particular, we have a CAN 1 and a CAN 2 input underneath. So you need to go from data cable from CAN 2, which is the output, and the input on each inverter is CAN 1. So we go CAN 2 to CAN 1. There's a number of cables here. We've got our other data cable, which runs directly to the genset over there, and that turns it on. We have another data cable that actually runs back to the switchboard, and we have 3-phase CTs that measure the current and voltage that is running from the genset to here. This is the brains of the whole operation, in particular this inverter. It's not a special inverter, it just becomes the master inverter. They're universal, these inverters, which are great. Now the other consideration when we're doing the installation design, being in Blackwater, the temperatures out here are like 45, 50 degrees. This is undercover. We left this open so that we could get air through here, and also the core filled concrete wall. This was all done by the customer. Being Earthworks, they concreted it and they had this prepared. They also had a booster. Heat is a killer of electronics, especially batteries and inverters. On these inverters, they can operate in a temperature range between -35 to 60 degrees. On this site, we've got 18 batteries. That's 104 kilowatt hours. And we have a depth of discharge of 80%. We're using about 85 kilowatt hours of actual usable battery capacity. That's just to protect the batteries. The batteries are warranted for 10 years. The inverters are warranted for 10 years. A lot of people ask me, yeah, but 10 years and 1 day, what happens then? The life cycle of this battery is actually 6,000 cycles. Now, if we deplete this battery once per day, which is the standard for a battery, if you divide 365 days by 6,000, it equates to around 16.4 years. So even though the warranty is 10 years for each of these batteries, the actual estimated life cycle is about 16.5 years. When we're reading the system on our portal, so I check this every week, for instance, on my phone, on my computer, the customer has access, they check it all, they can manage their own energy. We can see what the batteries are doing, we can see what the inverters are doing, we can see when the generator's kicked in. So these panels, by about 9:30 in the morning, are fully charging these batteries up to around 96, 97%, and also running the entire site. So this setup, even if they are grid connected, because this is a grid connect inverter, this is a battery connected inverter, and this is an off-grid inverter. This will work very well for small to medium agriculture, commercial facilities will run pumps. This setup, this design is perfect for that. So the end result of this system for the customer, originally they were spending about $1,500 to $2,000 a week in diesel. We've installed 224 solar panels, gave them spares in case of an emergency. We installed 18 batteries with 85 kilowatt hours of a usable battery, 105 kilowatt hours of actual battery, 6 inverters. We gave them a total of 450 amps output so we could meet their surge demand. We also used an inverter system that was IP55 and 65 rated for the Australian heat, so that we don't get major issues. We had Solax engineers actually attend site and commission the site, so they give us on-site support when dealing with AusPac Solar. And the customer has received, or as far as I'm aware, is very happy with the system, and they are saving approximately 90 to 95% of their energy bill. They were running off a diesel genset in the past, coupled with this existing genset that they are spending about $125 to $150 a week worth of diesel at current prices at the start of 2024. We've been able to achieve at AusPac a fully off-grid system that is saving a huge amount of money for the customer. And not only that, but they've actually secured their energy as a resource which they need to run their business for the next 10 years, because the warranties that we were able to provide off-grid is a full 10-year in-home warranty with support. We've got remote monitoring tools and the technology is there now. We're able to achieve what our customers need for an affordable price, so they have complete confidence in their product. An account manager that you can just go to as a customer, speak to, and have confidence that you will be looked after and that your system will work as it is intended.